Hi, hello, vanakkam, and welcome back to yet another episode on your favorite Little Slaw YouTube channel. And this is the fifth episode. And so far, in our four previous episodes, you must have understand how Locust works on a single machine. And now, in this episode, we're going to go distributed. So we are talking about scaling across multiple machines to generate 100,000 plus concurrent users. And let's scale up. So the challenge is you need massive scale, maybe 100,000 concurrent users. So even with the Locust's efficiency, that's too much for one machine, right? And here is the beautiful part. The same master worker architecture we just learned in the previous episode about scales seamlessly across multiple machines. So there's going to be no complex setup, no complicated configurations. Looks cool, right? And the next thing is, how does it work? So let me explain the distributed architecture in simple terms. So you designate one machine as the master, and this machine, the master machine, runs the web UI and it coordinates everything. This must be looking something similar to what we see in the JMeter master slave. The JMeter master actually take care of all these, right? So the same thing, but in a different way, right? So the master itself does not generate much load. So what happens is you add the worker missions as many as you need, and each worker connects the master and it waits for the instructions. And when you start the test, the master divides the users equally. So 10,000 users across 5 workers. So each worker is going to get around like 2,000 users, which if we distribute it locally equally. So as the test runs, the worker continuously send their statistics back to the master, and the master aggregates everything in real time. And finally, you see one unified result. Right? So when you see in the web UI in one unified view, and even though the load is coming from multiple machines, seamless, right? So it's going to be one unified test results. So how they talk, how they communicate, how do these machines actually communicate, the master and slave? So in JMeter we have this RMI interface, right? But how does it work in Locust? So master and workers talk over TCP on port 5557 through simple message passing protocol. So the critical point here is workers send the traffic directly to your target application, and the load does not go through the master because this prevents the master from becoming a bottleneck. And the workers send three things: the statistics about request, the heartbeat messages saying I am alive, and then the third one is the error reports. So the master sends the commands. So it starts spawning users, stopping the test, shutting down the test gracefully. So it's going to be like very clean and simple. And moving on to the next part where we're going to set up the commands. So let me show you the actual commands to run the distributed test. So on your test machine, run this command, the locust -f locust file.py, the Python file, and then the master bind, and then what host that we need to run. So the master bind host parameter tells it to accept the connections from any IP and not just localhost. On each worker machine, you have to run this command which I have sent you. So you have to replace the IP address with your actual machine, master machine's IP. And then one critical requirement, the exact same locust file must be on all machines, right? So if they are different, you'll keep getting errors. So always keep them synchronized, and that's the best practice to get it done. And then the capacity planning. So how many users can you actually run per machine? And this depends on your workload. So for light request, you can use small payloads, fast responses. You can even run 5 to 10,000 users per machine. For medium complexity, typical API calls with normal response times, you have to plan for like 2 to 5,000 users per machine. And for heavy requests, like large payloads, slow responses, complex processing, you can expect 500 to 2,000 users per machine, and these are guidelines. So always test your specific scenario, and you have to monitor the resource usage. And moving on to the next part, the monitoring. So here is something crucial that many people miss. So you must monitor Locust itself, not just your target application. So the CPU usage should be 60 to 80% during the test. And if you are hitting 100%, Locust is really struggling at that point and it needs more resources. And when it comes to the memory usage, it should remain stable, because if it keeps growing, you might have a memory leak in your test code. And when it comes to the network input output, it should be proportional to your request rate. So the maxed out network means you have found your bottleneck. And if Locust itself is overloaded, your test results are unreliable. So you might blame your application when really Locust cannot generate the load fast enough. So what are the pro tips that you would have to learn here? So let me share some hard earned wisdom from running the massive distributed test. Always start small and scale up. I always tell this for any tool. It can be LoadRunner, JMeter, or NeoLoad. Same applies here. Always start small and scale up. So begin with 100 users. Monitor every single thing, then gradually increase. Don't jump straight to maximum load. And for really big test, use headless mode without the web UI. So the web interface itself consumes resources, and for massive test, skip it. And then never run Locust on the same machine as your application under test. Separate your test infrastructure completely so that you will get a clean and accurate result. So what are the common mistakes that you can face, or which I will say that you will see these mistakes all the time, so avoid them. Use different Locust files on if you are using different Locust files on master versus workers, that's a big mistake. This will cause weird errors, so always keep them synchronized. And trying to run too many users on weak machines, just because Locust can theoretically handle 50,000 users does not mean your laptop can, so always know your limits. And writing blocking code in your tasks. So remember, G events efficiency depends on cooperative multitasking. Mainly the CPU intensive work without yielding will bog everything down. Always ignoring network latency between the workers and your target. High latency or packet loss skews your results. It will give you biased results. So test from realistic network locations. So finally, the summary. Now you must have understand by this time the Locust architecture from top to bottom. The green threads makes Locust massively more efficient than traditional tools, and this is the foundation of everything. And then the master worker model scales seamlessly from one machine to hundreds. Same architecture but unlimited scale. And then distributed testing lets you generate virtually unlimited load. Yes, I mean unlimited load. So if you need more power, just add more workers. And then always monitor Locust itself to ensure your results are accurate and reliable. And next is going to be episode 5, 6, where we finally start writing real load tests, and we're going to cover HTTP request, user behavior modeling, and building production ready test scenarios. And this is where it all comes together. So thanks for sticking with me through the architectural deep dives. So this knowledge will serve you in every test you write. So see you all in the next episode. Until then, it's bye bye from Mr. Shanmugam and your favorite Little Slaw YouTube channel. Take care and bye bye.